pay attention, and maybe things will look up or something. All right, so yesterday we finished our practice quiz. We got through 1 through 5. So now we're going to start on number 6. And number 6 says R equals 6 cosine theta. And the directions say, write as a Cartesian, rectangular, complex equation. Okay? So here we go. Who remembers? These are the ones that are a little bit tricky sometimes, but I gave you a really good hint. How did I tell you to start this kind of equation? Change the function, whatever it is, into its definition. So what is cosine?
Cosine is y.
X over r. So cosine is x over r. So no matter what the function is that's in the problem, whether it's sine, tangent, secant, whatever it is, it's going to be a fraction. You have a fractional definition for it. So now let's get rid of the fraction. So I'll multiply both sides by, in this case, r, because that's what my denominator is. Now, what about r squared?
X squared plus y squared.
R squared is x squared plus y squared. So look at this equation that you have left. It is a Cartesian equation. We're done. Now, for those of you that have forgotten that x squared plus y squared equals r squared, remember that triangle right there. Over x up y, that's r. So r is always x squared plus r squared is x squared plus y squared. All right, now number 7 is the opposite of that. Number 7 is a rectangular equation that we want to write as a polar equation. Now those are the easiest in the whole wide world. Those are simple. What does y equal? R sine theta. So I'm going to take out the y and put in r sine theta. What does x equal? R cosine theta. What are the variables in that equation? R and theta. It's a polar equation. We're good. There's nothing else we can, well, there are things we can do to it, but nothing that will simplify it. So we're just going to leave it very just like that. Yeah, that's pretty easy. And then number 8, we have a couple of numbers, 2 CIS 70 and 5 CIS 201. And we're going to do some things. We're going to multiply those two numbers together. All right, so this is 8A. Who remembers how to multiply numbers in polar form? Chandler?
The r's, you multiply the thetas get added.
We multiply the r's, add the thetas. So that would give us 10 CIS 271. And that's the answer. Everybody remember that? When we multiply numbers in polar form, we multiply the r's and add the angles. Right? Some of you are staring at me blankly. When we multiply numbers in polar form, we multiply the r's and add the angles. All right, now what about division? Now we are dividing the two numbers. So how do we accomplish the division? Divide the r's, so that'll be 2/5, and subtract the angles, so what is that? Negative
131.
131. Now, that is the answer that you get. But how about that answer? Not allowed to have a negative argument. This guy has to be between 0 and 360. So I'm going to have to rewrite that answer. This is the correct answer. You did everything correctly, but we need to rewrite it. So what will that be?
Add
229?
Yep.
Is that right? And that is the correct form of the answer. It's the same answer. Now it's in correct form. All right, what does this mean? Who remembers what that means? No, the next one is magnitude. This means magnitude. This is D now. D is the magnitude. What is the magnitude of this number right here? If you drew that number, how long would it be? It's 2. The magnitude's just R. Think about it. If you draw this number, you go over and up. Isn't that the length of the number right there? So the magnitude is always just R. What does that mean? Did I not? Didn't do that? Okay. Well, let's talk about that. That notation means the conjugate. Okay? That means the conjugate. So we're going to find the conjugate of this number right here. Now, before we do that, I want you to think about what you already know about conjugates. If you had a number like 2 plus 3i, what would its conjugate be? 2 minus 3i. Now, let's draw a picture of both of those. Here's the original number, over 2 up 3, right? Here's the conjugate, over 2 down 3. So here's a picture of the original, and here's a picture of the conjugate. What can you tell me about their R's? They're the same. So whatever the conjugate of this is, its R is going to still be 2. Now, here's the theta for the original. Here's the theta for the conjugate. What can you tell me about those 2 thetas? They're the same, but this one is positive and this one is negative. So the conjugate has the same R and the same angle, only negative. But you're not allowed to have a negative theta. Okay, now wait. Every time you do the conjugate, this is going to be negative. So every time you do the conjugate, you're going to have to fix it. So what will be the best answer then? What? 290. 290. We just need a positive coterminal angle. All right, since we didn't do that before, let's find the conjugate of z sub 2. The bar over the top means conjugate. So we're going to find the conjugate of our z sub 2. So what will that be? It has the same R, and it has a negative, the same angle, but negative. So when we clean that up, it will be what? 159, is that right? And that will be the conjugate. So in polar form, the conjugate has the same R value, negative theta value. In complex form, to get the conjugate, you just change that middle sign, right? Which takes you from going up to going down. That's why you have the angle change. Alrighty? Alright, well I'm glad we did that. Okay, so that's done. Now, go to the last page of your packet, which is Prequest number 2. Stu, this is going to be collected, so you want to do it with me, okay? You're going to turn this in. This is the point Stu gets. He turns in his classwork. That's smart.
At least he does in class, you know.
At least he does it. That's right. What?
Pretest or pretest?
It's pretest. Did I say quest? Sorry. This is a test. Pretest number 2. It says pretest number 2.
This is the only one I'm turning in.
You're turning in 2 pretests. I'm going to do number 2 right now. You're going to have to turn in number 1.
Okay.
It says that on your paper. It should say that.
It says pretest.
There's 2 of them.
Okay. So here we go. We're on pretest number 2. Note that little parentheses there that says be exact whenever possible. Now, kids, what that means is if we don't need a calculator, we're not going to use a calculator. So if the angles are like 60, I don't need a calculator, and I'll be doing it with the radicals. if the angle's like 50, then I'm gonna use my calculator because I can't do it exactly. Okay, so here we go. Convert to trigonometric form. All right, now, wait a minute. What do we mean by trigonometric form? That's polar form. So I want this number to be RCIS theta. I am looking for an R and a theta. We all know that, right? When it says do something polar, you need R and theta. So how do we find R and theta?
Square those and add them together.
Well, I'm going to draw a picture of it so that I can really get a good handle on my angle. I know it's going to involve squaring those and adding them up and taking the square root. It's a 45-degree angle. Keyshawn's already noticed that. So if you remember that the hypotenuse is root 2 times the legs, then you know that's going to be 4. If you're doing the Pythagorean theorem, that squared is 8. That squared is 8. 8 and 8, 16, and the square root is 4. So one way or the other, you're going to come up with 4. Your R value is 4. This is your theta, so be careful. What is your theta going to be? 180 plus 45 or 225. Try to get in the habit, kids, of when you write your answer down, just do a quick check and make sure you're in the right quadrant. Because if you put 45 here, which quadrant is 45 in? 1. That is clearly not in quadrant 1, right? Make sure your angle matches your picture. All right, number 2. Oh, we've already done one like this. Change to a rectangular equation. So what does that mean? We want x's and y's, right? So what's my hint? How did I tell you to do this? Change the secant. Okay, what is secant?
R over X.
It's reciprocal of cosine. Cosine is x over r, so this would be r over x. If you thought for 1 minute that you were going to be able to forget all that stuff, dream on, folks. Bad news. Now, multiply through to clear the denominator. So this one's a little different than the last one, but that's okay. We're clearing the denominator. And then what do you notice? You can divide by r and x equals 2. What was your job? What were you trying to do? End up with an equation that had x's and y's only? And that's what you've got. Done. Done, done, done. Good work. Okay? Number 3, change to rectangular coordinates. Okay, so we're changing to rectangular, but now we're doing it not with an equation, but with an ordered pair. Okay?
Wait, how can R be negative 2?
Well, we've talked about that. R can be negative, but it throws the point to the other side of the circle on your 90-degree switch. But I don't need to worry about that, kids. Whoa, wait a minute, wait a minute. What's your job here?
Just to make the coordinates change.
You're supposed to be finding x and y. X equals negative 2 cosine 300. Y equals negative 2 sine 300. Kids, I can't impress upon you enough. X equals r cosine always. Y equals r sine always. Now, if you want to change this point, go ahead. It's extra work that's going to accomplish nothing, but you can do it. X is going to equal r cosine. So now, if I'm using a calculator, I just type that in. But I'm not using a calculator because 300 is special.
30, 60, 90.
It has a 60-degree reference angle. which means this is a negative root 3, this is a 1, and this is a 2. Oh, this word, I have to remember that. Yes! You have to remember that. So what's the cosine? The cosine will be 1/2. So negative 2 times 1/2 is negative 1. What's the sine? Negative root 3 over 2, so that's just going to be positive root 3. So my job was to find the x and the y. The x is negative 1 and the y is root 3. How do I find x and y? R cosine theta, R sine theta.
How about the assignment? So on this our paper it says pretest and in-class review. So do we turn in pretest 2?
What did it say on there? Oh Lord, what did I do? Yes, I'm going to change that to both pretests. Or to do the in-class review as an in-class review. Yep. I should have, that should be both pretests, sorry about that. Because we're doing pretest 2 for you right now. We'll do the in-class review in class. Alright. Sorry about that, that's my error. So pretest 1 and pretest 2, that's what's due. Okay, where am I? Am I done with this? Did I finish that problem?
Yeah.
Alright, so now I'm ready for number 4. Convert to standard form, that means Cartesian form, complex form, rectangular form. Convert it to regular form. So it is right now in polar forms. What form do I want that to be in? X plus yi. Beautiful. That's the form I want. In other words, it's almost identical to the problem I just did. Don't I have r and theta, just like I had before?
Yeah.
I'm looking for x and y, just like I did before. The difference is, instead of putting them in an ordered pair, I'll put them in an answer like this. I put this one in an ordered pair because the problem was an ordered pair to start with. This is not an ordered pair, although it represents the same thing as an ordered pair. All right, so what's x? X equals 4 cosine 240. Y equals 4 sine 240. And here we go. 240. Special. What's the reference angle for
30, 60,
240?
90
That's a
with the
60
quadrant.
again. Be careful, these are both negative. So what's the cosine?
-2.
No, not negative 2. Negative 1/2. So x comes out to be -2, if that's what you meant.
Yeah.
X comes out to be -2. And then the sine is negative root 3 over 2. So y comes out to be negative 2 root 3.
Nothing yet though.
Is that right? And then our answer, we want to write it like that. So it'll be -2 minus 2 root 3 I. Our answer is x plus yi. That is complex form, rectangular form, standard form, Cartesian form. That's anything but polar or trigonometric. Okay, so that was 5. Now we're finding polar coordinates. Okay, so what does that mean? Now we have to find r and theta. So we're starting with -3, 3 in problem number 5. And we need to find r and theta. right, how do we do that? We draw a picture. Over 3, up 3. Here's R. R will be
Root 18.
root 18, or 3 root 2.
45, 90.
That angle is 45. Does everybody recognize that without a calculator? But your actual theta has to be 135 to get you into the second quadrant. So there is your answer.
Has to be negative. The R has to be negative.
Is root 2 off?
No, in number 5,
Oh,
R
yeah.
is positive.
Okay.
In number 5, I'm doing problem 5. Now, in a minute, I'm going to do 6, and yes, that has an R situation on it. It's over
Wait,
there.
so how do you get 3 root 2's on kind of weird?
Square root 18.
Oh, yeah, so that's, yeah. Oh, that's 3 2, okay.
Alright, so now I'm going to do exactly the same problem, but I'm doing it with this point. So I'm going to do exactly the same thing. I am not going to let this bother me. I'm not going to pay any attention to that. I'm going to do the problem and then I'll deal with this. Okay, so here we go. 2 root 3. What's my R? 4. What's my theta? 60. And for the first time all day, can I use 60? Yes. So 4 comma 60 is the answer when I change this into polar coordinates. The problem is, this problem stipulated that the R value has to be negative. Okay, make the R value negative. It doesn't change a thing about how you do the problem. You just have this add-on step. Make R negative. What happens to the angle when you make R negative? You add 180 or subtract 180. You change it by 180. So these are exactly the same point, gang. These are exactly the same point. They would be plotted right on top of each other. But this particular problem wants that version of it.
When you drew the arrow to get the 135, how come that this one you didn't go through the triangle on the last one?
The angle here is over here in the second quadrant, John.
Right.
The angle here is right here. I start on the positive x-axis and go till I hit my angle.
On the, oh, I see. So you have to go through
between 0 and 360.
the angle, so like on number 4, you have to draw it through to get the 240.
I draw whatever I need to draw to get to the diagonal line that's representing the angle.
If it's not, it changes.
Yes.
If those 2 points are exactly the same, what is the purpose of having 2 ways to write it?
Okay, when you solve, some equations, I have not had you plot points, we just typed them in on the calculator, but if you were plotting points, when you set up a T-chart in polar coordinates, like when we do x, y, you pick x's and plug them in and get y. When we're graphing in polar coordinates, we have our theta set by the graph paper that we're using. We plug those into our equation, and often, when you plug them into the equation, you'll get a negative R value, which will really be 3 comma 225. But when you do the T-chart, it will come out with a negative R. So even though I'm not having you graph with the T-chart, I want you to be familiar and comfortable with, what do I do if I have a negative R value? You can't plot it. It is impossible to plot a negative R. So you have to rewrite the point and plot the new point. Okay. Besides, Tomas, it just makes it more fun.
That's true.
All right, what am I ready for? 7? 3x plus 4y equals 8. These are the no-brainers. You wanna write that as a polar equation, you take out the x,
And just plug in.
and you plug in r cosine theta. You take out the y and plug in r sine theta, and you are done.
That's all it is.
That's it. Now, 8, we've already done one, or we've already done a couple today, but let's do another one. Here we go. This is polar,
Fill it in for x over.
so we're gonna fill in for cosine. Whatever the function is, we're gonna fill in for it. So cosine is x over r, right? Right, guys? Okay, now we'll clear the fraction, so r squared equals negative 2x. R squared is x squared plus y squared. And there's your equation. Right, look familiar? We've already done one exactly like that today. Alright, so that's number 8. Now number 9. Find the fourth roots of negative 8 plus 8 root 3i. Answer in rectangular form. Oh crap. That's not good. Alright, but here we go. What do we mean by fourth roots?
To the 1/4 power.
To the 1/4 power. So we're going to raise this to the 1/4 power. It doesn't matter what power you're raising it to, the process is the same. Okay, so we're going to use de Moivre's theorem. So we're going to do what with that number right there? We need to change it into polar form. You can't do de Moivre, you can't raise this to the 1/4 power until you've changed it. So negative 8, 8 root 3. Alright, yes, it's a special triangle. Keyshawn has recognized that's a 60 right there. How long is that radius? 16. Now again, if you can't see that, then you're going to do the Pythagorean theorem. You're going to square 8, square root 3, square 8, add them up, take the square root, it's going to be 16. So your number is 16 CIS, be careful, 120 to the 1/4 power.
And you raise 16 to the 1/4. And then you times 120 by the 1/4.
So now we're ready to do the log, which says take 16 to the 1/4 power and take 1/4 times 120.
2.
So that'd be 2.
Right? So 16 to the 1/4 means the fourth root of 16. So 2 CIS 30 is answer number 1.
Oh, yep. We gotta add, we gotta divide.
Remember, these fourth root or any root problem has more than one answer.
Add 90 to it 4 times.
How many answers does a fourth root have? 4. How far apart then will they be? 90. So if the first one is at 30, the next one will be at 120. The next one will be at 210. And the last one will be at 300.
Great.
So let's put them in rectangular form.
Okay, so these are the polar form answers to the question, right? So if it said answer in polar form, we got it. But it doesn't, unfortunately. So we're going to divide and conquer this.
Rectangular form now.
So we're going to change it into rectangular form, which means find x and y. And that side of the room over there, you guys are gonna do the first one. Middle, you're gonna do the second one. You guys are gonna do the third one, and I'm gonna do the fourth one. And we're gonna have all of our answers done. I hate to have all of us do all four of them because they're done exactly the same way, right? X, for me, doing the last one, X is 2 cosine 300 and Y is 2 sine 300. Depending on what your angle is, you're gonna have exactly the same thing with a different angle. All right? Now I'm gonna go ahead and do mine. You're doing yours. If you don't know what to do, ask your neighbor. So I have mine done. So I wrote my answer in rectangular form, x plus yi. Anybody have yours done?
Yeah. Almost.
What's the third one?
We're at
Oh, is it negative root 3 minus I?
That sounds really good to me. I think that's right. Anybody over there have the next ones done? Yours is root 3 minus I. That should be root 3 plus I believe. Negative 1 plus root 3i sounds good. Yep. So there are the answers in complex form. All right, number 10. Name the classical curves. So there are 4 of them. Who's going to list them? Lemniscate, limousin, spiral,
3 petaled roses.
rose. That's right. So we have the rose, the spiral, the limousin, and the lemniscate. Those are our classical curves. Look in your notes, they're all spelled there. All right, number 11.
Do we do 10?
Find the value of negative 1 minus root 3i to the 6th. Is this like the one we just did?
Yeah.
The only difference is this only has one answer. How's come it only has one answer? It's not a root. You only have the multiple answers when you're rooting, when you have a fractional exponent. This has one answer. All right, let's find it. What do we have to do? Same thing we did over there. We need to change it. So, let's see, I need R and theta. R is 2 and theta is 240. And that's what I'm going to raise to the 6th power now. Alright, so how does that work? How do we raise that to the 6th power?
2 to the 6.
2 to the 6. 64. Oh lordy. And then 240 times 6. Is that 1440?
Yeah.
Way too big.
Take 360s out.
Take 360s out of it, and actually, does that boil right down to 0?
Yeah.
That goes all the way down to 0. So here is your polar form. That's it. We're done. except it said answer in rectangular form.
Not done.
So we're not done, we gotta do this. So x equals 64 cosine 0, and y equals 64 sine 0. Okay, now zero's special, right? I mean, really special. Zero's on the circle. What's the cosine of 0? 1. What's the sine of 0? 0. So it's just 64, or if you want to say plus 0i, that's fine too. That kind of helps remind you it's x plus yi. All right, number 12. Let's see if we can get through number 12. We're going to multiply these two numbers together. Okay, we've already talked about this today. How do I multiply these numbers together?
Add the, or multiply
I
the r's.
multiply the r's.
Add the thirds.
So that would be 72. And I add the angles.
42.
Come on, these should be easy points, right? All right, how do I divide? Now I'm doing z sub 1 over z sub 2. So the division will be
Divide and subtract.
2/9 CIS negative 80. Gotta change that.
2/9.
So negative 80 changes to 280. Is that right? All right, C, what does this mean? Now we've talked about it. That means the conjugate. And when I do the conjugate, now it's z sub 2, so make sure you're looking at the right number. We leave r the same,
18.
and we make the angle negative. So our final answer would be 18 CIS 260. Everybody still with me? And the last one, make sure you're looking at the right number. It means the magnitude or the length of z sub 1, and that's just its r value, so that is 4. All right, tomorrow when we gather, we will do 13 and 14, so this one will be finished. And then we will start the in-class review to wrap up one more piece of it. Okay? You feel like you're ready for it? Well, we have one more review day.
Almost.
And then we'll be ready for
I'm
it.
about to C right now.
All right? Do we by any chance have a long period tomorrow?
Yeah.
Oh, do we?
We have one afterwards.
I know, how exciting.
Does that mean we get a review day?
Yes, that means we'll get everything done probably.